We are working on activity 5 in the electricity packet. It looks like this. You will need to first make predictions. What we're going to do is set this compass underneath the wire once I have it hooked up and the light bulbs are lighting. And I want to know, how does the activity in wire A compared to wire B compared to wire C? Are they equal, or something greater than or less than the other one? So you're to put those in there. And then the next one says, predict the direction in the amount of compass deflection for each wire in the diagram. The direction is going to be, does it deflect clockwise? If it deflects clockwise, it would go in that direction. That would be clockwise, and I'm going to just use CW. If it's not that direction, the other one would be, does it deflect this way, counterclockwise? So it's the opposite direction of what a clock moves. So those are your two choices. And then they also ask you what the amount is. It's going to be kind of hard to see that amount on this video. I'll tell you about what percent it is moving about, what degrees it moves. And then the last one asks, if I reversed the battery pack, so instead of being hooked up like this, if I turned it and hooked it up like this, how would that affect the compass deflection and the amount? So that's what they're asking you. I'm going to have to move the camera while I do this so that you can see the compass deflecting. So we're going to start with the first one. So before we start, I would like you to make your predictions first. So you can stop the video and make those predictions. Okay, now we are ready to continue on. You are supposed to fill out these two charts as we test the wires at positions A, B, and C. So this is my first one. I'm going to hook this up. You cannot see the host setup. You can see the one bulb lighting over there because I had to kind of zoom in here. So here's my wire A. When I put it over the compass, oh, it looks like it deflects, not a lot, but see how it moved? It deflected this direction that I'm looking at the red needle. That would be clockwise. And it looked like it deflected about 10 degrees. Okay. Now I'm going to move my wire because I have the compass taped down. And so this was wire A. I'm going to get this one out of the way. It's still going to be hooked up though. There's the light bulb. So this is wire B. I want to keep it orientated the same way coming off the battery. Oh, see that deflection? That was also deflecting this direction. Like it was clockwise again, and it looked like it was 10 degrees. Okay, so that was wire B, the second wire. Okay, now I'm going to bring around the other bulb, and this is wire C. I have to keep them orientated the same because I want to just test what's happening in the wires. So here's wire C. Oh, looks like that one, when I take it away, it falls back to being horizontal. When I bring this here, it deflects, and it looks like it deflected clockwise again. And it looks like it deflected 10 degrees again. Okay, so I'm going to set my stuff back up, move my wires back around. I'm going to be back over here to wire A. Now, when I do this, I'm going to reverse the battery pack here. So here's my battery pack. So I'm going to reverse it. So I'm going to unhook it. I'm going to turn my battery pack around. So this time it's a negative terminal here and it's a positive terminal here. Yes, the light bulb's still light. And I want to look at, how does my compass deflection compare now? So when I do this one, here's wire A. I bring this up. Oh, it looks like the needle deflected counterclockwise. It went this way, CCW, and it looks like it deflected about 10 degrees again. See it deflecting? Then when I pull away, the needle goes back to its resting position. So then when I'm going to pull these wires over here, wire B, I'm going to put this one on. Oh, same thing. Counterclockwise, 10 degrees again. And then my last wire, wire C, and I have to keep the wires orientated the same. There it goes again. It looks like it's counterclockwise again. 10 degrees. So that would be our results from the lab. Now, I want to take a few notes here on a conclusion and some new terms. So, for our conclusion, I'll move my camera here. Write these on the whiteboard. So for conclusion, it looks like every wire had the same amount of deflection, 10 degrees, and it looked like, didn't they all deflect in the same direction when I had the battery hooked up in one manner? So we're going to say all wires had the same amount of deflection, that was 10 degrees, and all wires deflected in the same direction for one setup. So in other words, when I had it set up one way where I had the positive over on the positive here on that terminal and the negative here, and I hooked it up, all the wires deflected counterclockwise. When I had it flipped around and I reversed it, they all deflected clockwise. So that's what we're looking at. So that's telling us a couple things. One is it's telling us that whatever is going on in the wire, the same thing must be happening in all the wires. Okay? So this is what we're kind of getting to is charge. That's what we are detecting with the compass deflection. Around every current-bearing wire, and that's what this would be, these are all bearing a current because right now this bulb is lit up, there is a magnetic field. And so when you bring it up next to a compass, you get that deflection happening. Okay? So that compass deflection is due to the charge that is moving in the wire. So in other words, charge is what is moving in the wire. So in all of our wires, A, B, and C, they all deflected the same amount, so that must mean the same amount of charge is flowing in each wire. Now, on a circuit, there is something called conventional charge flow. So I need to erase this. Conventional charge flow is this. So scientists 120 50, 200 years ago got together at a convention, so that's why this is called conventional, and they decided they were doing all of these different experiments with electricity. So they decided we're going to all decide that this is the way charge does flow. Does it flow in this direction? So if you look at my circuit, if I bring my circuit over here, here's my battery, my wires, my other bulb, two bulbs. So does it flow this way around the circuit, or does it flow this way? So if it flows this way, we would call that clockwise. If it flows this way, we'd call that counterclockwise. Okay? So they didn't know which way it flowed, so they said, we're going to all agree upon one way. So this is the way that they agreed that electricity flows, because they all had to have some kind of parameters set up for when they're doing experiments. So they said charge flows in a closed loop and we have figured that out. We've noticed that we have to have a conducting material in order for charge to flow in a direction that is away from the positive terminal of the battery towards the negative terminal. Okay. Now, in a battery, we've kind of talked about this. There's two terminals on the battery. There is the positive terminal, which has the little knob on the top, and then the negative terminal, which is down here, the flat end. Okay, so we are saying if this is the positive, the charge flows away from this and it comes back around to the negative. Okay, so on my packet here of this circuit that I have set up, if I look at this, here's my battery pack. If I look, this one right here is the positive terminal. So in this case, charge would be flowing from this positive through the wire to the first bulb, and then it would go through the second wire, back around here to the second bulb, and then it would come back to the battery pack here to the negative terminal. Okay, so that concludes experiment or activity number 5.